Hi everyone, my name is Saman. I'm a PhD student at Western University in Canada, but right now I'm at EPFL in the tribology lab. Let's have a brief introduction about me at Western University, which is located in a beautiful city of London. I'm a third-year PhD student in the Department of Chemistry, and I'm working in an amazing group under supervision of Dr. Yolanda Hedberg. I am working on the corrosion and degradation behavior of biomedical alloys upon exposure to body fluid. Metallic implants throughout their service life may experience extreme chemical and mechanical circumstances. The effectiveness and durability of the implants are significantly influenced by patient characteristics like BMI or any types of infection. In addition, different modes of damage may occur simultaneously or synergistically for implants exposed to physiological environments, depending on the implant material, design, and biological environment. In this regard, I am trying to characterize the surface of retrieved implants with the focus on knee and hip implants to see, in the first place, what types of damage had happened on the surface of these implants before revision surgery, and is there any possible correlation between the damage types and damage extent and patient factors? One of the most common types of degradation is tribocorrosion. It is the simultaneous action of corrosion and mechanical wear. As this type of damage could be found prevalently on both hip and knee implants, I was really interested to learn more about this phenomenon. Thanks to CREATE CORRECT program, I was provided with this opportunity to study the tribocorrosion behavior of titanium alloy Ti64 in the tribology and interfacial chemistry group at EPFL in Switzerland. EPFL University is located in the beautiful city of Lausanne in the French part of Switzerland. During my stay in the tribology and interfacial chemistry group, I had this opportunity to work with Dr. Ana Igual-Miones and Dr. Stefano Mistler, and of course with friendly colleagues who made a great time for me. This group is active in the field of advanced tribology as a multi-scale discipline at the interface between material science, mechanics, and surface chemistry and physics. Their research interest is focused on the scientific understanding of the interactions between nanoscale surface features and tribological system behavior and at developing predictive multi-scale models including mechanical, chemical, electrochemical, and material factors. In addition, the group has developed a particular expertise in the field of tribology in aqueous system, which is called tribocorrosion, including fundamental and applied aspects in specific areas such as biomedical implants. Trying to work on the tribocorrosion behavior of titanium alloy Ti64 in the sodium chloride solution, and in order to try to model the physical mechanisms and physical phenomena that is happening on the surface during the rubbing. So here you can see the setup which is already been assembled. We have the arm and the ball is already assembled on it, so it's a sort of ball on flat. Valuable information could be obtained from tribocorrosion measurements and surface characterization. For example, the change of current versus time could be indicative of repetitive destruction and formation of surface oxide, or how formed particles during rubbing can affect the coefficient of friction as a function of time. Surface characterization of the wear track by taking advantage of confocal microscopy can help us to determine whether there are third bodies or not. Evaluation of the surface of the ball can reveal important information regarding the characteristics of the material. SCM and FIP could be helpful to recognize tribologically transformed surfaces. And finally, on the last day of my stay, my friends gave me this wonderful gift, which motivates me to finish my PhD as soon as possible to become a doctor, and then I will be able to use this knife. The geography of Switzerland is playing an important role. The presence of mountains and hilly terrains have been protecting this country from the attack of other countries and nations over the past centuries, and that's why Switzerland has always been away from world wars. The privilege of being naturally shielded from any attacks, as well as Switzerland's policy towards any wars during history, has placed this country in a neutral position and made it as a symbol of wealth and prosperity. This country holds a great global position by hosting numerous organizations such as World Health Organization or United Nations. It is worth mentioning that while inaccessible geography of Switzerland has helped this country to escape all major wars around it, it could be one of the factors influencing the standard of living for the people of this country. The unique geography of Switzerland can also produce poverty and social inequality. Jura, Valais, and Ticino are three cantons in Switzerland that they are struggling with lower levels of prosperity compared to the other cantons. Because of their mountainous geography, these three regions are lacking from developed infrastructure, agriculture, as well as vocational schools, which are the roots for a lower quality of life. Only about 20% of the population of Jura has a university degree. This number for Valais is about 27%, and for Ticino is 32% compared to average for Switzerland as a whole, which is 37%. So the unique geography of Switzerland can act as a two-edged sword. It can protect the country from any wars, or it can encourage tourism, but at the same time, it can cause inequality and lower standards of life for a specific group of people.